Okay. What did I say for? Oh, me. Okay. Oh, there he is. Yeah, just you have to do the best you can with it until you can get that to post. Okay. No major announcements. So this is the end of week 5. Just, you just want to be sure that you're making your way through our assignments. And also be sure that you're making your way through our material for the lab, right? So we meet with Dr. Lamar. She's facilitating the lab. So, that's another component you can also be working on. So today we wanted to just kind of continue with section 1.4. We're going to work on answer as many homework questions from that section together as we can. Check Zoom one more time. I don't think he's here. This one. Okay. And as usual, if you have questions, feel free to unmute yourself to get my attention. And we can talk about any questions that you may have. Oh, we got booted out? Okay. All right, so this is week 5, so we're here. This one. All right, this one asks us to write a linear function that has the indicated values and sketch the graph. So let's start getting a copy of this. And I'll check attendance again in another 6 minutes. Just give them a little bit of a chance to get into the waiting room. All right. So when we kind of introduced linear functions, there were 3 equations that were recommended that we have ready to go. But I found that we've really only been using like 2 of them, which is the slope formula, y2 minus y1 over x2 minus x1. And oftentimes we finish in the slope-intercept form, which is y equals mx plus b, right? So let's list out the ordered pair that we're given, or the information that was given. When x is 0, y is 10. When x is negative 10, y is 0. Okay. Come on. So then when I have an ordered pair like this, I like to label it x1, y1, x2, y2. So then the slope between these points is going to be 0 minus 10 over negative 10 minus 0 is negative 10 over negative 10, which is 1. All right. And then I think in this example, or this question, they gave us our y-intercept when x is 0, y is 10. So they gave us our y-intercept. So then if we want the linear function between these 2 points, our f of x is going to be 1 times x plus 10. And we can confirm, we just want to verify that our given points work here. So notice that when x is 0, y is 10. When x is negative 10, y is 0. So we just got x plus 10 Okay. Oh, and then the graph. So when x is 0, y is 10, I think A is the only one that has those intercepts. So I'm just gonna go with the A. Let me check Zoom again. Okay. So this was similar. Let's just start by getting a copy. And let's take similar notes and just account for the changes. Okay. So we're asked to write a linear function. So we're going to use a slope formula. y2 minus y1 over x2 minus x1. This is our slope. Also use mx plus b. So we're going to say y equals mx plus b. Okay. Let's identify the piece of the information given. Come on. So when x is -1, the corresponding y is 2. When x is 4, the corresponding y is 17. I'm a fan of labeling x1, y1, x2, y2. And let's find our slope. It'll be 17 minus 2 over 4 minus a -1. 15 over 5, which is 3. And as usual, if anything is not clear, feel free to unmute yourself to get my attention or type in the chat. I check the chat periodically. So then we want to go back and try to find our y-intercept. I'm going to use that first point. It just looks like it's less of a headache than the second piece of information. So with our slope being 3, when x is -1, we're solving for b, our y is 2. Okay. So then from here, we get that b equals, add 3 to both sides, we get 5. So then our linear model, f of x, m, so it's going to be 3x plus 5. Okay. And it's a good idea to confirm that our original information works in this model. So, come on. So notice, when x is -1, we get 2, so that one checks out. When x is 4, 4 times 3 is 12 plus 5 is 17, so this one checks out. Okay. So 3x plus 5. We got 3x plus 5. So that means our y-intercept is 5 and has a slope of +3. So since the slope is positive, it can't be a and b. And then between c and d, the only one that has a y-intercept of +5 is c. So I'm going to go with c. Okay. So find the intervals over which the function is increasing, decreasing, or constant. Here, I would just recommend to look at the graph, right? You notice that the highest exponent is a 1, so we should be working with a line. The y-intercept is 3, and it has a slope of 4, of +4. So then that means that as we trace the graph left to right, it's gonna rise. So it's going to be increasing. It's going to be increasing across this entire domain of all reals. It's never decreasing, and it's increasing on all rails. Negative infinity to infinity. And then it's never constant because it's going to always be increasing. Okay, so with that one, I mean, I know it didn't show the graph, but that one we kind of visualize the graph. This one, same kind of deal. Identify the intervals over which is increasing, decreasing, or constant. If you were to look at this graph, it's kind of like an S shape that passes through the origin, but it's going to be all increasing across the entire domain. Let's see it in action. 4x cubed. Right. So notice as you trace it left to right, it's increasing and it never decreases. So it's increasing across this entire domain. So that's going to be C. It's decreasing, it's never decreasing, so we're going to go C there. Constant, it's never constant, so we're going to go here. Okay, let me check Zoom one more time. Nope, they are missing. I have to check my email. Okay. So this question is exploring even, odd, or neither. All right. Let me see. So we have three different ways of discussing even, odd, or neither. The simplest way is like if you're looking at the graph, an even function is going to have y-axis symmetry, and an odd function is going to have origin symmetry. Another way of discussing even, odd, and neither is like, okay, an even function, whenever you have the point x comma y, you also have negative x comma y. So that's kind of like using symmetry. An odd function being symmetric about the origin, whenever you have x comma y, you also have negative x comma negative y. All right, so in the even case, we only change the sign of x. In the odd case, we change the sign of both x and y, right? So that's kind of, we're using symmetry here. So for instance, we were given that first point is negative 100 comma 5, but then you see on the tail end, we have 100 comma negative 5, where both the sign of the x and the y both change. And so if you keep comparing the second one to the second to last, both change there, and there's, you know, so since both the x and y are changing, in this case, we would say that this is odd. With this one, so I think it's the same thing, right? Because both the signs are changing in each case. So we're going to go out again. Okay. So, you know, we kind of did an audible recap on pictorially, what does it look like when an image is even, i.e. have y-axis symmetry, or when an image is odd, symmetry with respect to the origin. Then what we just saw was like an example using symmetry. It's this thing where even functions, whenever we have x comma y, we also have negative x comma y. And in odd functions, whenever we have x comma y, we also have negative x comma negative y, right? So this case is going to kind of be an application of what we were just doing in the previous, where we're going to solve algebraically. Right? So let's start by, we're going to determine whether this is even, odd, or neither algebraic. Let's start by getting a copy of this guy. Okay. I'm going to hop over here. And drop that image here. Cool. Okay. So let me start by showing the definitions of even, odd, or neither. So the definition of oh, come on. This has been doing this all day. The definition of a function being even means that when we evaluate f of negative x, we get back to the original. The definition of a function being odd means when we evaluate f of negative x, we get negative times the original. Okay. So in this case, what we're going to do is we're going to replace each x with a negative x, simplify, and analyze. So the first thing we're going to do is replace each x with a blank set of parentheses. The blank parentheses helps us to keep track of our signs. So we're going to say g of x equals 6x cubed minus 2. And we're replacing each x with a negative x. Negative x. So now when we go to simplify, here we're multiplying an odd number of negatives. So we had to ask ourselves, will the final result be positive or negative for that term? In this case, the final result is going to be negative. Nothing happens with that second term because there's no variable there. Then we ask ourselves, okay, is this the original? Which is a no. Can we get it to where we'll have negative times the original? So if we factor out a negative from these terms, it won't get to negative times the original either. So this is an example of a function that is neither even nor odd. Okay. Keep going. So similar here. I think I'm gonna just speak through this one. No, let me write it out. I mean, looking for you on the copy. Let me take that and drop it here. Okay. So again, one of my professors would say, every time you use a formula, write it down. Thank you. So the definition of a function being even, when we evaluate f of negative x, we get the original. Odd means when we evaluate f of negative x, we get a negative times the original. Okay. So we're going to start by replacing all of our x's with a blank set of parentheses. Okay. And then we're going to substitute negative x for all the x's. So then when we simplify, we're multiplying the odd number of negatives, so that's going to be negative. This is also going to be negative. Then we ask ourselves, is this the original? No. But if we factor out a negative, we should be able to get negative times the original. Notice this is indeed. So now we've shown that f of negative x equals a negative times f of x. So that's the definition of a function being odd. Okay. So that this is an example of something that we have. Let's give this one a go. Break this down to get it on one page. Let me start here. Of course, that's what it's going to do. I think if I put this like this, I just can't get those to separate. I'm just gonna leave it like that for now. I think you guys will be okay. Okay. Come on. Okay. So again, even f of negative x, we get back to the original. Odd means f of negative x, we get a negative times the original. So first we're going to replace each x with a blank set of parentheses. X squared minus 4x over 6 times x to the 4 plus 5. Then we're going to replace each x with a negative x. So then the first term becomes positive. Second term becomes positive. Third term becomes positive. And the 5 just comes down. So then we ask ourselves, is this the original? We're going to say no, because of this guy here. And we can't get to negative times the original either. So this is an example of something that would be neither. Okay. Okay. Another one. So the graph of a function is given to the right. You use the graph to find each of the following domain and range, right? So for the domain is the very left to the very right. The far left for this one, okay, I'm going to use brackets because we're including this number. The far left, x goes to -1. The far right, x goes to 8. And we include both of these numbers because it's defined when x is -1 and it's defined when x is 8. Okay, there are no holes or gaps or breaks, so every x between those is accounted for. The range is the very bottom to the very top. So this is going from -1 to 2, and we're using brackets for a similar reason. Okay. X-intercepts, right? Okay. So I was working this one with the last student. I don't know. I was making one small error during my calculations, and it took me a while to find it, but I was totally like a zombie. I was so sleepy. We want to look at, so if we want to find the x-intercept here, what I'm going to do is find the equation of the line through those 2 points and then use that formula to find the x and y intercepts, right? So 3, 2, and then -1, -1. 3, 2. So I'm basically finding the equation line through these 2 points. I usually like to label x1, y1, x2, y2. And I know we're going to be using a slope formula. y2 minus y1 over x2 minus x1. also going to be using our slope intercept. So that's our y equals mx plus b. Okay. Let's go ahead and find our slope. 2 minus a -1 over 3 minus -1. 3 over 4. Okay. They didn't give us our y-intercept, so we need to find it. I think I'm actually use the second point because I think that just looks a little bit more simple. So then my slope was 3 by 4. We're going to check it when x is 3. We're solving for our y-intercept, and the corresponding y is 2. So then ultimately, it's going to be 2 minus 9 over 4. Okay. 4 times 2 is 8. So minus 9 is going to be -1 by 4. Okay. So that's our y-intercept. Okay. So then the equation of the line through those 2 points that we get is f of x equals 3/4 x minus 1 by 4. Okay. So then if we want the x-intercept, we set y to 0 and solve. Okay. So then we would have 3/4 x minus 1 by 4 equals 0. Add, and multiply by the reciprocal, a third. Okay, so our x-intercept is positive 1 by 3. Then our y-intercept is a -1 by 4. Increasing, decreasing, or constant. So if we look at the graph, as you trace the graph from the left to the right, it's increasing as x goes from -1 to 3. So for the discussion of increasing, decreasing, and constant, we use parentheses. We said as x goes from -1 to 3, close parentheses. Okay. Continue. Decreasing, it's not decreasing anywhere, so we're going to go with B. And then constant is constant as x goes from 3 to 8. Parentheses, 3 up to 8, close parentheses. So this is interval notation, not to be confused with an ordered pair, right? Those are two different concepts. Is a function even, odd, or neither? So even means y-axis symmetry. There's not y-axis symmetry. There's not origin symmetry, so it's not odd. So it would be neither. Okay. So I think this is the furthest that I've made it with this set all day. Just, I've been doing like this set of homework. This is my 4th time going through this set. I mean, the questions, the numbers change, but if it's the same question, it's just like, by the time I get to you guys, I'm like struggling. But this is new. So we got like a solid 10 minutes. Let's take advantage of it. What are the intercepts? Okay, it looks like they're given. It looks like the x-intercept is what? -1 and 2. I'm just going to go with that for now. -1 and 2. Okay. So I just looked at the graph. The y-intercept there is 2. Thank you. The domain, so the domain is going to be the very left to the very right. So the furthest left x value is going to be when x is -3, and it's included. So I'm going to use a square bracket, -3 up until +3, and close it off with the square bracket. I'm using the square bracket because this graph is defined at these x values. The range is the very bottom to the very top. The lowest y value is 0. And again, it's a bracket for the same reason as the previous. And the very top is 3. And bracket, close bracket. Okay. So we just got lucky with this graph. On which interval is the graph is increasing? Okay. So it's increasing on 2 intervals. It seems to be like 4 main sections. You got, 1, 2, 3, 4. It's increasing as x goes from -1 to 0. So we use parentheses here. -1 to 0. And I'm going to say comma to identify the next interval. It's also increasing as x goes from 2 to 3. So I'm going to say parentheses, 2, 3, close parentheses. Okay. So then if we could talk about increasing, we should be able to also talk about decreasing. It's decreasing as x goes from, so I'm going to say parentheses, as x goes from -3 to -1. Close parentheses, comma, open parentheses. It's also decreasing as x goes from 0 to 2. Okay, we're going to go with that. Okay, continue. Constant is, it never flattens out anywhere, so we're going to say the graph is not constant on any interval. Okay. Is there any kind of symmetry? No, right? Symmetry is like, can you fold it along? If you fold it along the y-axis, it doesn't match up, and it's not symmetric about the origin. So this is neither even nor odd.
So one question.
Yes.
So there'd be no symmetry when it's neither odd or even, right? Like.
Yeah, no symmetry.
Okay. All right. Thank you.
Okay. Let me see the time. Okay, this will be the last one. It says the graph of a function is given to the right. Use the graph to find each of the following: the domain and range. Let's just go ahead and do that. So the domain, this looks like an exponential function, or it's a log function. Okay. So the very left, if this is log, the very left is going to be the y-axis. The y-axis serves as a vertical asymptote that we never touch in this context. So the far left is going to be 0, and the far right is going to be positive infinity. But we group the 0 with the parentheses, which means we get really close to it, but we don't reach it. Go ahead.
I have a question.
Yes.
So I was doing this yesterday, the domain, and why is it not negative infinity? Because because you see how the log is going like it's coming like up. So like wouldn't that be like negative infinity to infinity?
Let me pull this up on, let me hop over to Notability to do this reply. So I just got a clean copy of this. And let's hop over here. Oh no. So hang on, come on. So you got a favorite color?
Just blue, I guess.
Okay. And let's go like this. Style. Let's make it thickens like this. Okay. So when we're talking about domain, the domain is the very left to the very right, right? So we can use this bar, right? How far left does it go? Now, for our picture, it stops here, but you have to understand the concept that it gets really close to this dash vertical line, right? So if this is log generally has a vertical asymptote. So if you say negative infinity, you're saying that there's an x over here. You have to be aware that our graph does not cross this vertical asymptote. It gets really close to it, like it.
Oh, okay.
Yeah, it
So,
does.
but it'll never pass that line.
Not for logs, right? Because the domain for log is basically 0 to infinity. So everything to the right of 0, right?
Okay.
That's domain. Domain is the very left to the very right. Yeah, I think that's about the simplest way.
Okay, I got it.
Go to that one. Come on. Okay. So that's the domain. Then the range. So if the domain is the very left to the very right, the range is the very bottom to the very top. So let me just showcase range. Anybody got a favorite color? So we did the domain in blue. Got another favorite color?
Just red, I guess. Yeah, red.
Red. Okay, that's interesting. And so we'll do the range in red. Okay. And instead of being vertical, we're gonna go like this. And then basically, like I think we did like that one. We did, come on, this one. That's fine. So then the range is the very bottom to the very top, right? So let's move the blue out of the way for right now. And so the range, like so we're asking ourselves, how far down does it go? Can it go off the graph? Yeah, because if this is log, we're just limited by the graph, but it continues on going down. So no matter how far down you go, you find a corresponding x. Similarly, no matter how far up you go, you can find a corresponding x. Like if I'm here, you see, like it crosses here, and so the x is here. All right. Say I'm like down here, well then it's gonna cross here, and the corresponding x is here. All right. So range is the very bottom to the very top. All right. So the very bottom in this case is going to be negative infinity, and the very top is going to be positive.
Okay, that makes sense.
So then what's the range? It's time, trying to.
The range? Negative infinity to infinity.
Yeah. All right. Okay. Let me see. Let's see what else we got. Continue. X and Y intercepts. Okay. So the x-intercept, they gave it to us. You can see it. It says it's 1.0. And I think there's no y-intercept because it does not cross the y-axis. That's the property of logs. So we're going to go here and we're going to put, okay, I'm just going to put 1. Okay. I'll continue. Okay, increasing, decreasing, or constant. Let me see. So as we trace this left to right, is it going up or going down? This one is going down the whole time as we trace it left to right. This one is never increasing and is decreasing over the entire domain. But the domain here, again, we got to go back to the domain for this guy. It goes from 0 to infinity. So it's decreasing across the domain. So as we trace it left to right, it's going to be going down. It's going down. Okay. Continue. I'm just trying to wrap it up, and then we can get some more questions in there. And it never flattens out, so it's never constant. Yep. Even no symmetry, right? Because even means y-axis symmetry. So if you fold this on the y-axis, it doesn't match up. Odd means origin symmetry. This is not symmetric about the origin. It doesn't even pass through the origin. I don't think that passing through the origin matters, but the main thing is that you don't have points. Yeah, this is neither. You don't have points that are symmetric about the origin, right? Let's keep going. Okay. Did you guys have more questions? We have a little bit of time. We're pretty much out of time, but did you guys have any other burning questions before we go our separate ways?
No, I'm good. Thank you.
Twice. Okay. So if there aren't any burning questions, let me go ahead and load a copy. So again, everything that you saw me writing, you can add, but I've also been dumping pretty much all the notes for all of my college algebra courses in one folder. So when you open up the folder, you're not only going to have you all stuff, it's going to be stuff from my other classes, but I usually label them so that you can identify which class is which, right? So, where that information is coming from. The main thing for us, do the best you can. You need to be making your way through our material that's on Pearson. Hopefully you all have linked up with Dr. Lamar, and you just need to follow her instructions. And basically twice in the semester, she's going to give me a grade for each person. Now, I just kind of want to mention this. No matter where you are at the midterm, you don't have to stress too, like if you're not doing well at the midterm, you don't have to stress too much about it. The midterm grade, what it is, it's just a snapshot of where you are at that moment in time. It has no bearing on your final grade. It's not even going to be in your transcript at the end of it. What matters is that final grade, right? So if the midterm comes along, if the grade is what it is, and like, okay, well, I just haven't submitted this stuff yet, but I plan on submitting it, then, that's one thing, right? I just don't want you guys freaking out about midterm grades. Midterms are just saying, hey, this is where you are at this moment in time. You still have time to get caught up. So it just kind of creates alerts and flags like, hey, do we need to track down somebody? Do you have a plan to finish, or, you know what I mean? That's really the intent of that, okay? All right, so if there aren't any other burning questions, we're going to end the session here. And from one beautiful mind to another, stay dangerous. Peace.
Good one.
Have a good day, sir.